Hi, welcome to the second video for today. We're going to talk about quadratic functions for this one. There are some other things with quadratic functions we're going to do at a later time, but for right now, we're just going to concentrate on the vertex form. You've already talked about the factored form. For a minute there, I almost lost my brain. Oh my goodness, I felt like the scarecrow in The Wizard of Oz. Let's go ahead and get started. This is going to be the parent function. Again, you're going to be working with your partners and creating this on one coordinate plane using different colored rubber bands. And my suggestion for a while would just be to use -2, -1, 0, 1, and 2. And so, of course, if we use that, -2 squared, of course, is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So go ahead and pause the video and make these 6 functions and see what they look like. Hi, welcome back. Of course, the parent function of this that we're talking about is f of x is equal to x squared, and this is called a quadratic. Okay, it is one of the very few that is very strangely named. Okay, the domain, of course, is going to be, that's right, -infinity to +infinity. But let's take a look. When we went ahead and graphed that original parent function, and let's go ahead and do this one up to here. What we noticed at this point was that it actually was a parabola, okay? And oh, that's just an absolutely horrible looking thing, but it's close enough. So it is kind of a U-shaped type of thing, but take a look at the range, okay? The range, the y value starts here and goes up. And so the range in this case is a square bracket, 0, to +infinity. The y-intercept, of course, is 0, 0, and the x-intercept, of course, is 0, 0 as well. Hopefully you know the answer to this question right here because there is a reflection across the, that's right, y-axis, in which case this makes this an even function. Not only that, hopefully you remembered that if all you see is even exponents, that it is an even function. Oh, but is it a one-to-one function? Well, let's take a look. Mrs. Rose draws a horizontal line. Oh, no. It goes ahead and crosses at 2 points. So each y is not unique to each x. So while this is a function, because every x is unique to y, it is not true on the opposite. So no, this is not a one-to-one function. Oh, increasing or decreasing. Well, remember in that case, what Mrs. Rose does is she draws her handy-dandy pretend linears. And what does she notice? She notices that it is decreasing because there is a negative slope. So my decreasing interval is from where to where? That's right, from -infinity to 0. And my increasing is from, that's right, 0 to +infinity. Now notice, guys, we haven't been talking about end behaviors, but I hope you're doing your end behavior dance. You know, the one, as x approaches +infinity, we do this. As y approaches +infinity, we do this. Yada, 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 okay? Go ahead and pause the video if you need to make your nice and pretty parent function books. All right, what happens if A is negated? Hopefully you remember to use the negative sign, and there is a squared key. If you notice that you have a squared key on the left-hand side of the graphing calculator, you can use that. If you don't see the squared key, remember that you can go ahead and enter for y equals x raised to the power of 2, okay? And then negated x raised to the power of 2. Or you can just use the square key. Remember also to change the settings here. So what happened when A was negated? Hopefully by this time you've seen the pattern, and you would tell me that, that's right, the function, what? I didn't hear you, reflects over the x-axis. That's right. So go ahead and write that and graph your examples using different colors. Pause the video and wait to move on. All right. But what happens if the coefficient A is greater than 1 and the coefficient of A is between 0 and 1? Let's go ahead and pause the video and set this up, okay? Let's go ahead and use x squared, 3 times x squared, and 1/2 times x squared. Don't forget to change your settings. Go ahead and pause the video until everyone has this in the graphing calculator, and then go ahead and remember to hit Zoom 6. That will give you the standard site, and yours will match mine. Welcome back. Is this what you saw? I hope it is. What happened if the absolute value of A was greater than 1? The coefficient was greater than 1? That's right. That was called a vertical stretch. That's right. It's moving towards the Y. And if it was a fraction between 0 and 1? That's right. It's a shrink. It's moving towards the x-axis. Very good. Go ahead and pause the video and let's graph. Don't forget to use different colors. And also, those of you who tend not to write things down, let's get this written down. I'm watching you. All right, so welcome back. What happens if there's a vertical shift? That means what happens if we change K? All right, what happens if I see a positive K? And what happens if I have a negative K? Why don't you stop the video for a second and talk to your partners? Look at the previous parent functions and see if you can make a good conjecture. That means, can you make an educated guess? Welcome back. Let's go ahead and put these into the graphing calculator, making sure the settings are changed, and then pause the video for a second. Are you back? Did you hit Zoom 6? Did you get it looking like this? I hope you did, and I hope for your conjecture you knew that if you had a positive K, it was going to have a vertical shift up, and a negative K was going to have a vertical shift down. Very good. Go ahead and pause, graph, and more importantly, write the details. You're going to need these details for your project next week. All right, so what about the horizontal shift? Why don't you go ahead and write what you think will happen to plus h and minus h? Have you got it? Go ahead and pause the video for a second and talk to your partners to see if you can already figure out what's going to happen based on what we've already discussed for the last 2 days. Welcome back. Why don't you go ahead and put this into your graphing calculator? Please notice that the horizontal shifts are always in a parentheses with the x. They are not outside of the parentheses because if they were outside the parentheses, they would be a vertical shift. Pause the video. Hey there, did you get what I got? Hey, look at how cool this looks. It shifted to the left when you had a positive h, and it shifted to the right when you had a negative h. I hope you remembered that, and I hope you get that written down in your parent function book, because even though we're not collecting these on Friday, I am spot checking them for a grade on Monday for you. Okay? Pause the video and let's graph. All right, by this point you know the drill. Under the important notes, I hope you'll write the vertex form of this quadratic. I hope there's also a lot of space left because you and I are going to talk a little bit about some other formats that you might see a quadratic in. But at this point, this is the most important one for me. Okay? What do you think you should have written in the important notes? Well, hopefully you have that if A is negative, it reflects over the x. If the absolute value of A is greater than 1, it's a vertical stretch. If A, oh my goodness, Mrs. Rose, you just somehow don't know what you're doing today. If The absolute value of A is a fractional or decimal equivalent between 0 and 1. It's a vertical shrink towards the x-axis. Negative 8, horizontal shift right. Positive 8, horizontal shift left. Positive K, vertical shift up. And you know what that leaves us with? Vertical shift down for a negative K. You can pause the video if you need to go ahead and get this information down. All right, so pause the video here. Notice this is math.about.com, and this is about the functions. All of the parent functions are listed in this location. Finally, if you've got a moment, let's create absolute value or quadratic functions on your coordinate planes and see if your partner can write the new equation based on the changes in A, vertical stretch or shrink, horizontal shift, or vertical shift, okay? Then go ahead and put that equation into the graphing calculator and see if the graphing calculator's graph matches your coordinate plane. What kind of expert are you for today? We're done for Tuesday. Tomorrow is a new day. See you in the funny papers. Bye-bye.